So now before we actually solve right triangles without using a calculator, I'm going to give you a summary of what we've talked about today. So far we've talked about three types of triangles. The one that will give us a 30 degree at the bottom, right angle, and understood to get a 60 degree up there, but let's just forget it at this time. We don't really need that idea. The ratio between the three lines on the triangle will be 1, 2, and root 3. The hypotenuse will be twice as long as its opposite side. The triangle that will give us 45, 45, 90 will give us the same length for its opposite and adjacent, with its hypotenuse being root 2. You can get this value using the Pythagorean theorem. And finally, the one that comes with a 60 degree is simply a rotation of your first triangle, because you are getting a 30 degree up here, and the line opposite to this 30 degree will still be a 1. The longest side, the hypotenuse, will still be twice as long, and the third side would then be root 3. So when we are to solve any right triangles that involve 30, 45, 60, or any angle in standard position that will give us these three reference angles, we can now solve those triangles without using a calculator. Sometimes people find it easier to have all three triangles turn into ratio and put them into a table. So when it comes to sine 30 degree, sine 30 degree, 30 degree for your sine ratio, opposite over hypotenuse, that will give us 1 over 2. And then if you are working with cosine 30 degree, cosine 30 degree would involve the use of adjacent and the hypotenuse. And that will give us root 3 over 2. So now if I'm to use the same concept to come up with the tangent ratio for 30 degree, or the sine ratio for 45, or the rest of it, I'll be able to complete this table. 45. So that will give us 1 over root 2, 1 over root 2 again, and we look at that one, tangent 45 equals 1. Sine 60, cosine 60, and tangent 60. Some of them come with a radical in the denominator, and you will be able to rationalize your denominator using methods you've learned earlier this year. I can rationalize the denominator for this. I can also rationalize the denominator for that ratio. So you may want to multiply the top and bottom, in this case, by root 3, giving us this ratio. Or you can choose to, for this case, you can choose to multiply the top and the bottom by root 2. This is how you rationalize your denominator, giving us root 2 over 2. Or you can keep it for now, and once you're done with your calculation on your triangle, for your triangle, you can then rationalize your answer at a later time.